Hello all. So welcome to this last lecture in week 1 of this course on time series forecasting with applications in R. So the idea for this lecture is just to summarize very quickly as to where we stopped last time. So this entire idea about stationary processes and non-stationary processes, etc. And then I'll devote the entire time by playing around a few things in R. Okay. So as even mentioned in the outline, this is a kind of a practical course. So many of you might not be very acquainted with the statistical software R. So maybe what we can do is we can just run through the entire process one more time. So how do you install R, and then how do you play around with a few numbers here and there in R, alright. So we'll deal with that. Okay. But again, just before that, just to finish this idea about stationarity and non-stationarity. So converting a non-stationary process to stationary, and why is it important? Okay. So again, just to summarize very quickly as to what do you mean by a non-stationary process. From last lecture we've seen that either if you have a trend or seasonality or cyclicality for that matter, or changing variance. So these are some of the key ideas as to when a time series process would be non-stationary. So again, just to summarize this quickly using some graphs. So let's say if a time series is trending upwards, then it will be non-stationary. Or if you have seasonality, so seasonality means repetitions. So let's say temperature data or rainfall data. So or is a seasonal, right? So you have some specific repetitions here. Okay. So again, the time series is non-stationary. And lastly, changing variance. So changing variance means what? So let's say initially the variance is small, but then it grows. All right. So this is a problem of changing variance. Okay. Now the idea is, why do you have to convert a non-stationary process to stationarity before you move on? Is as the distributions, moments and probability laws keep on changing over time for any non-stationary process, and one can see that if you have a trend, then it's really hard to put one distribution on top of all the individual time points, as discussed in previous lecture also. Okay. So hence we have to convert any non-stationary components of a time series to stationary as much as possible before you try to model or before you try to forecast and so on. Okay. And again, one more idea is that this is also done for simplicity, because as discussed in the last lecture, if a time series is stationary, then the mean is constant, the variance is constant, the covariance or the correlation does not depend on time. So the entire process is more like in a statistical equilibrium. So it's really easy to kind of handle and try to put a distribution on top of that, or try to model that and eventually try to forecast. Okay. So hopefully this very important point is clear, that if you have any non-stationary aspects underlying in a time series, the very first idea is to convert those and then transform them into a stationary kind of a series. Alright. Alright, so now let's shift attention to R. I'll show you that how exactly you can actually install R. So I have this web page in front of me which gives you R Studio for desktop. Okay. Now I'll strongly recommend that rather than installing the plain R, you should actually install R Studio, because R Studio is more user friendly, and then it has like inbuilt options where you can import some packages and then play around much more freely. Okay. But in order to install R Studio, you actually have to install R first. So go to this website, right, and then first download and install R from by clicking this button, and then you have to actually download and install R Studio also. Okay. So to the rest of this course, whenever we have some practical session in between, we will try to do all those things using R Studio directly. Hopefully this is okay. Alright, so now we will shift and then I will show that how exactly R Studio framework looks like. So if some of you have already seen this, then it's a very good thing, but for those of you who do not have a flavor of either R or R Studio, then this is exactly how a typical window in R or R Studio looks like. Okay. Now of course, just for simplicity, from now on if I mention R, it means R Studio. So I will not mention R Studio every time. Okay. So if let's say we'll do this in R, or we'll work this out in R. So R actually means R Studio, which is this framework firstly. Okay. Alright, so here just to tell you more about the panes that you see here. So let's say, so initially on top on the left side, this is the coding pane. So I can actually write down any code, I can actually code it in form of a program and then try to run this. Okay. And then down here you see the console. So console is where you can actually input some numbers, input some equations and then get the output. Alright. So, I will say that this is more like if you have to do a few things on the go or on the fly, okay. And whatever you will do here, it is actually stored in this environment, or you see history. So, if you have to see which codes did you run earlier, right. So, you can actually go to history, okay. And this is more like the directories on the computer that you have. So, let us say if you want to import something directly from here, you can do that. So, it says files. So, all sort of files that you have here and all the plots that you have here. So, let us say if you try to plot something, then those plots would come here, okay. Alright, so initially again we can pay attention to this console here. So, let us say I can write down a few things here. So, let us say 5 plus 2 or something like that, which is 7, okay. So, I can actually use this as a calculator also. So, 5 plus 2 or 10 minus 5, so 10 into 5, right, or 15 into 2. So, I can do all sorts of things using the calculator, okay. So, which is one very good thing. And now this is the area where you can actually write down a program and then try to run it line by line, okay. So, what I have taken here is that just to tell you and just to acquaint all of you with very basic R operations. So, you see here that the code name is basic R operations in R. So, by the way, any file that you create here would be stored as a .r file somewhere, okay, would be stored as a .r file somewhere, alright. Just before that, ensure that if you are playing around in R and you want to save some codes or save some output somewhere, you have to create a separate working directory for this course. Again, this is a strong suggestion from my side that keep a separate working directory, give it a name, let us say NPTEL time series course R files, something like that, okay. And in order to see that what is the current working directory, you can actually input get wd. So, get wd and then open brackets. And if you hit enter here, you will see that the current working directory is nothing but this. So, users and then OneDrive and then documents, right. And you can actually change this. You can actually change this according to whatever folder you have made. So, for that you can go to the session and then set working directory, right, and then choose some directory. So, let us say if you choose some directory, and then for that matter let us say if you go to desktop or anywhere, I have created one working directory specifically for this course, which is named as TSM R material, okay. So, time series modeling R material. So, you can open that, right, and then this tells you that the working directory has been changed to that folder, alright. So, again just to repeat, so again just a suggestion from my side that if you want to keep all the material that we will do in R in this course in one particular folder, let us say on your desktop or somewhere else, then changing the working directory is important, okay. And how do you do it? You go to session again and then set working directory and then choose whatever directory that you have created on your laptop, alright. Okay. So, my current working directory is this one, which is TSM R material, right. Now, we will walk around briefly over this code here that I have. So, again like I said that this is a very basic code just to acquaint all of you with some specifications as to how you can import some vectors or how you can input some numbers, right, and so on and so forth. Okay. So, initially if you see in this line 7 for that matter, we are basically assigning the value of 12 to some variable which is x, right. So, assigning any value to some variable in R, I can actually use an arrow sign. So, x and then arrow and then whatever number I want. So, let us say 12, okay. So, I can actually do this. So, I can actually do this using an equal to sign also, but then a more professional way is to use a arrow sign, okay. So, arrow tells R that the number 12 has been assigned to the variable which is x, okay. So, by the way, if you want to run any line, right, so you have multiple options. So, you can either go to this run here, so it runs that command, right, and the moment you run any line of this code, you can see that that has been reflected in the console. So, can you see this? So, in the console it says that we have successfully run the 7th line here, okay. So, now if you want to see that what exactly x is or what exactly the value of x is, so you have to run the next line which is x, okay. So, let us say if you run this, it will tell you that x is nothing but 12, alright. So, since we have assigned the number 12 to x, it gets reflected here. And the console is one area where you can see all the outputs, either whatever you type in here as a calculator or whatever line you run from the code itself, alright. So, I will do a slightly different thing now. So, let us say if I change this to some other number, so let us say 24, okay. Now, again what do you do? So, let us say you again run this line. So, x is now 24, and if you want to check it, then you have to run the next line where you have written down x, and then again it will tell you that x happens to be 24. Okay. So, let me change this to 12, which was there earlier, okay, and again try to run this line, and so again my x is nothing but 12. Okay. Now, in the code itself I can combine a lot of basic mathematical operations which one can actually perform on x. So, let us say I can add a constant or subtract a constant or divide x by some constant, right, or multiply x by some constant, and line 16 is x to the power 2, right. So, this inverted triangle kind of a thing means you are basically raising x to the power of 2. So, x square basically. Okay. So, let us see what each of these commands would give you. So, x plus 2 should give me 14. So, you see 14 in the console, x minus 2 is 10, x divided by 2 happens to be 6 clearly, x into 2 should give us 24, and then x to the power of 2. So, x square basically should give me 144. Okay. So, in short, once you assign any value to any variable here, I can perform any basic mathematical operation which I want, right. So, addition, subtraction, multiplication, division, power, etc. Alright. Okay. So, point 3 is, let us say if you want to save some output from the previous operation to some other variable, let us say y. So, how would you do it, right. So, let us say the initial x is, so remember what x is again. So, you have to keep this in mind. So, x is 12 in our case, right. So, x plus 2 should be 14, right, and then let us say if you want to save that output to a new variable which is y. Okay. So, I can again perform a very easy equation here. So, y and then arrow, because we have to assign it, and then what do we assign? So, we assign x plus 2. Okay. So, if you run this and then again try to find out what y is, so hopefully y should be how much? Y should be 14. Alright. So, now a sub point here. So, let us say showing the result of an assignment as you do it. So, sometimes handy for debugging. So, let us say instead of, so this point is, let us say if you have a very lengthy code, right, or first we will see that what it will give you. So, again let us say y arrow x plus 2, but then within brackets. So, can you see here that, so if you are keeping brackets in, or if you are assigning brackets around the same function, it will kind of tell you the exact function predominantly, right. So, let us say if you want to debug, if you want to find out that where exactly the problem lied in your entire code, right, then I can actually go back and then backtrack, alright. It is another way that if you are dealing with some lengthy codes, then it is kind of slightly easier to handle brackets rather than open ended equations, alright. Okay. So, now the next point is how do you define a list containing multiple numbers. So, let us say if you want to assign a vector. Okay. So, for assigning vector to any variable in R, you can actually use a C command. So, C and then within brackets you assign the numbers. So, 1 comma 2 comma 3 comma 4. Okay. So, what this means is that you are actually assigning this entire vector containing 4 numbers 1, 2, 3, 4 to the variable x using the command which is called as C. So, by the way, C in R is called as concatenate. So, concatenate means combine, right. So, essentially what you are doing is you are basically combining these 4 numbers as a collection or as a vector, alright. So, let us say what happens if you run this. So, and if you want to find out what my x is, so your x is nothing but a vector now containing these 4 numbers. So, 1, 2, 3, 4. Okay. Now, surprisingly I can actually do all the mathematical operations we did earlier on the vector itself, okay. And then we will see what results we have. So, let us say x plus 2. So, x plus 2 what it will do? So, x plus 2 is nothing but it is basically adding 2 to each number. So, 3, 4, 5, 6, okay. Or let us say x minus 2. So, x minus 2 hopefully it should subtract 2 from each number, something like this. So, minus 1, 0, 1 and then 2, alright, and then x divided by 2. So, x divided by 2 should give you 1 half, 1, 1.5 and then 2, right. And similarly x into 2. So, x into 2 multiplies each number with 2. So, 2, 4, 6, 8. Alright, and then lastly x square. So, x square should give you the squares of the corresponding numbers. So, 1 square, 2 square, 3 square and then 4 square. Okay. So, I think this would be very handy if you want to kind of rearrange a few things here and there, or if you want to assign some mathematical operation to a vector itself, right. Okay. So, now R works on lists. So, small comment here that R works on lists and then not vectors, and hence you must use special forms of mathematical operations to perform matrix operations correctly. Alright. So, I think this is telling us that how do you deal with matrices. So, probably we will see that slightly later. So, we will try to import a matrix, okay, and then we will try to manipulate the matrix itself. Okay. So, what you mean by this point is that we have an example here. So, let us say we will assign this entire vector containing 8 numbers to y. Alright. So, 1, 2, 3, 4, 5, 6, 7, 8. Now, again how do you assign any variable with a vector? You use C command. Okay. So, let me run this line and then let us see what y is. So, my y is nothing but 1, 2, 3, 4, 5, 6, 7, 8 as a vector. Okay. Now, let us see what happens if you try to multiply your earlier x that you had with this new vector which is y. Now, remember one thing. So, what was x? So, again if you are not sure what x is, you can again write down x and then hit enter. So, my x is a vector containing 4 numbers 1, 2, 3, 4, and what is y? So, my y is a new vector containing 8 numbers 1, 2, 3, 4 up to 8. Okay. Now, again going back to the important note that are things that you have these two lists and then not vectors. So, if you try to multiply x into y, we will see what happens. Okay. So, this is probably not what we want, right, because what R has given us is slightly strange. So, 1 and then 4 and then 9 and then 16. So, what it has done is it has taken x 1 by 1, the numbers in x 1 by 1, and it has multiplied the numbers in y 1 by 1. So, 1 into 1, 2 into 2, 3 into 3 and then lastly 4 into 4. So, 1, 4, 9, 16. But again strangely, since we have exhausted all the numbers in my vector x, it again goes back to the first number that we have. So, let us say, so 1 into 5, then 2 into 6, then 3 into 7 and then 4 into 8. Okay. And this is a problem because the length of these two vectors is not matching, right. So, the length of my y vector is 8 and the length of my x vector is just 4, right. So, handling this is slightly strange, which is probably not what we want. So, eventually the output is 1, 4, 9, 16 and then 5, 12, 21, 32. So, again my suggestion is that keep on playing on your end also. So, try to take different vectors, right, of different lengths if you want, and then try to perform all these operations and then see what you get. For example, I can also do x plus y or probably x minus y or x divided by y, right. So, try to see yourself as to what you get. So, rather than repeating each and every operation again on both these vectors, so try it out yourself. Okay. All right, and then now the next thing is how do you import some matrices, right. So, let us say, so what exactly is x again? So, x is, remember, x is 1, 2, 3, 4. So, vector containing 4 numbers 1, 2, 3, 4. Okay. So, now if we if you want to multiply that vector with its transpose. So, first transpose is what? So, transpose is nothing but if you have a column vector, then convert it to a row vector, or if you have a row vector, convert it to a column vector. So, transpose of a matrix, okay, very basic linear algebra. So, multiplying any two matrices, we have to actually use a special function which is percent star percent. Okay. So, you have to actually write down the star in between two percentage signs. So, x and then percent star percent, its transpose. So, now we will see what R gives us. So, now it gives us a matrix for that matter. Now, remember one thing that when you write down any vector and assign that vector to some variable in R, it kind of considers that vector to be a column vector. Okay. So, again remember what x was. So, x was 1, 2, 3, 4. So, think of it as a column vector. So, you have one column consisting of these 4 numbers 1, 2, 3, 4, and then you are actually multiplying that column vector with its transpose. Okay. So, if you have a 4 cross 1 vector multiplied by 1 cross 4 vector, which is the transpose, eventually you should get a 4 cross 4 matrix, which you see here. Alright. and matrix multiplication is performed as per the rules. So, if you are not very much confident about multiplying matrices, I think this would be a very right time to slightly go back and then try to revise the matrix multiplication first. Okay. Or what we can do is we can again invert it. So, transpose of x multiplied by x, and then here it should be a scalar, because remember that transpose is now a row vector. So, 1 cross 4, and then if you multiply that by a column vector which is 4 cross 1. So, eventually the answer should be 1 cross 1, which is scalar. Okay. And now we can actually go forward and then do lots of things using matrices themselves. So, let us say how do you create a matrix using some inbuilt function. So, by the way, one very big advantage of R is that R contains lots of inbuilt functions, for example, matrix, right. So, matrix of y comma 2, and we are assigning this matrix to some other variable which is z1. So, first let us see what you mean by, or what you get as z1. So, my z1 is nothing but such a matrix. So, 1, 2, 3, 4, 5, 6, 7, 8, right. Now, remember what R has done here. So, R has taken the entire vector which is y. Now, remember what y is. So, y is nothing but 1, 2, 3, 4 up to 8, that vector, right. And now, if you perform this matrix function on y specifying how many rows you should have, right. So, the first number that you specify is how many rows you should have. So, we are telling R that we should have 2 rows, right. But if you note that how R has assigned the numbers. So, it has assigned the numbers column wise. So, it has filled the first column first, 1, 2, then it has moved on to the second column 3, 4, then the third column, and then the fourth column, right. So, if you are not very happy with this structure, you can actually mention by row equal to true, alright, and then assign it to a slightly different notation so that you do not get confused. So, let us say Z2. So, what is Z2 now? So, Z2 is the same matrix which is y comma 2, but here instead we mentioned this extra thing which is by row equal to true. Now, let us see what R gives us. So, my Z2 is what? So, Z2 is, again it consists 2 rows because you have mentioned 2 here as the command, but then since you have mentioned by row equal true, it kind of fills the values row wise, right. So, it fills the first row first. So, 1, 2, 3, 4, and then the second row 5, 6, 7, 8. So, depending on how do you want to place the numbers in the matrix, you can actually write down by row equal to true or just skip that, alright. Okay, so I think the next idea is again important if you want to extract some numbers. So, let us say select a specific element. So, I can actually extract some numbers from a vector using a square bracket. Okay. So, again I will tell you what x is if you do not remember. So, my x is nothing but 1, 2, 3, 4, and then let us say if you specify x and then within square brackets 1. So, what it means is that you want to extract the first element of the vector x, right. So, what should it be? The answer should be 1 ideally. So, we will see if it gives us 1 or not. So, you can see that the answer is 1. Okay. Now, the second one is if you want to extract the second element from the same vector. So, x and then within square brackets 2, alright. So, it should output the second element which is 2, alright. Now, one can actually select a range of elements also. So, let us say if you want to select all elements starting from the second position to the fourth position out of this vector x, okay. So, what this should give you is nothing but 2, 3, 4, or I can actually drop an element also. So, for dropping an element I can use a minus sign. So, let us say x and then within square brackets if you write down minus 2, right. So, this means that you are actually dropping the second element, right. Or eventually I can drop a range of elements also. So, let us say if you want to drop all elements from the second position to the third position, then I can use a minus sign and 2 colon 3. So, this colon actually means a range, right. So, from the second element to the third element within some rounded brackets, alright. So, since you are dropping the ones in between, now my x is only left with these 2 which is 1, 4, alright. Or I can specify which elements to drop or which elements to select, right. For example, something like this. So, let us say initially I assign a slightly new vector containing only 2 numbers 1, 3 to y, okay. Let me run this. So, now if you want to see what y is, right. So, my y contains only 2 numbers now which is 1, 3, okay. And now this is a very interesting way of extracting the elements in y from the vector x, Okay. So, x and then within square brackets if you specify y, then we will see what happens. So, this will give you 1 3. So, essentially what I am doing is, since y is 1 3, right, I am telling R that I only want to extract the first element and the third element from my x vector, and the answer is in front of you, which is 1 3, because x was 1 2 3 4, right, and then if you are extracting the first element and the third element, I have 1 and 3 with me, right. Or if you include a minus sign here, it actually tells R that you want to drop those elements. So, let us say I want to drop the first element and the third element from my vector x, and the answer should be 2 4. Okay. So, again obviously it is not very easy to cover each and every function in R or each and every inbuilt equation in R. So, you have to actually try it out on yourself. Okay. So, by the way, all these codes would be shared to you, do not worry. So, maybe install R and then try playing around with some functions or not. Okay. So, for example, the next thing is combine two lists. So, how do you combine two vectors, right? So, let us say if you want to combine x and y. So, again use a standard C command. Okay. So, and then again, by the way, I am assigning the combination of my x vector and y vector to x again, right. So, let us see what this would give you. So, if you run this concatenate x comma y and then see what x is. So, now my x is 1 2 3 4 and then 1 3, because remember what y was as defined earlier, probably here, right. So, now my new y is nothing but 1 3. Okay. So, if you want to combine x and y, it should be 1 2 3 4 and then 1 3. Okay. Now, how about reversing a list? So, reversing a list means you want to output the numbers in a reverse order. So, you have a function called as REV, stands for reverse, of course. So, if you apply REV on x, it should give you 3 1 4 3 2 1. Okay. Now, the next thing is one can actually test for some logical operations. So, whether 1 equals 5 or not, obviously the answer is no. So, it tells you false, okay, or whether 1 equals 1 or not. So, answer should be true, right, or test some inequality. So, by the way, inequality can be specified using exclamation mark and then equal to. Okay. So, 1 and then exclamation equal to 5 means not equal to. So, is 1 not equal to 5? Answer is yes. So, the output should be true, and is 1 not equal to 1? Answer should be false, because 1 is equal to 1, right. So, answer is false. Okay. Now, how do you assign, or how do you tell that I have to specify some vectors in a range directly? So, you have multiple ways again. So, let us say colon, as discussed a short while back. So, I can write down 1 colon 3. So, 1 colon 3 means 1 2 3, by the way, okay. Or I can tell R to input a sequence instead. Now, sequence, the short form is SEQ, right. So, within a sequence you have to specify from which number to which number, and then what should be the jump size in the sequence. So, by how much jump should you keep on changing the number. So, here if you let us say keep 0.12, then what R would give you is this vector. So, first number is 0, next number is 0.12, the next number is 0.24, and remember the last number should be 1, right. So, R has stopped at 0.96, because after 0.96 it would exceed 1, okay. Or there is one more another way of assigning numbers in a sequence. So, first number is 0, second number is 1, and length. So, you can tell R as to how many numbers you want, okay. So, something like this, alright. And then down the line you can actually have other inbuilt functions such as mean, variance, standard deviation. So, let us say if you input x vector, I can find out the mean of x, which is 2.5, or the variance of x, which is 1.66, or the standard deviation, which is 1.29, right. Or you can sum all the numbers in x. So, summing a list. So, let us say sum of 1 2 3 4 is 10, or take the product of all the numbers. So, product is 24, or find out the length of x. So, length of x should be 4, right, which is what you see here. Okay. So, I guess these are some very basic commands. I mean, again, just to sum this up, you should try to install R in your own PCs or laptops, right, and then try to open this worksheet if you can. Try to play around with some functions. I mean, input some vectors using C, try to manipulate some numbers here and there, okay. So, I guess this is a very basic worksheet on R. So, maybe down the line, of course, on a weekly basis, we'll cover some time series aspects and then try to blend all the theory using some practical ideas in R. Okay. So, since time crunch, we did not talk about lot of different things, let's say plotting or how do you assign some distribution to random variables in R, right. But of course, down the line in subsequent weeks, we can kind of cover that and then try to link all the things with what has been taught in that particular week. Okay. Thank you.